In this video, we're going to take a look at section 6.8 on complex numbers. First, we'll start with introducing this concept. I kind of referred to it earlier in, I think, section 6.6, but now we're going to officially introduce it and start using it. It's called the imaginary number. The imaginary number I is the number that, when squared, equals -1. Mathematically, symbolically, that looks like this. Right, I squared, right? I is the number that when you square it equals -1. If you were to take the square root of both sides of this, that tells you that I is equal to the square root of -1. Now remember, back at the beginning of chapter 6, we talked about this scenario of having a number that when you take the square root, how do we say it? I'm saying it wrong. Let me start over again. We talked about the situation of taking the square root of a negative number and how we actually could not resolve that. Because, for example, if we were looking for the square root of -25, we're looking for a number that when we square it equals -25. And we talked about how there was no number that would do that, because whenever you square a number, it always comes out positive, right? 5 squared is +25. -5 squared is also +25. Right? I'm sorry, it's kind of hard to read. Because when you square a negative, -5 times -5 also comes out as +25. And so no real number, when it gets squared, would ever equal -25. So our response to that earlier was, this is not a real number. And so we're actually going to find a way of resolving this by using something that is not a real number. It's an imaginary number. So the imaginary number will give me the negative sign that I need. So I already know how to get the 25, right? 5 squared will give me 25, but to get that negative sign, I need to have an I with that, right? So if I take 5i and I square that, I'll get 5 squared times I squared. The 5 squared gives me 25, and the I squared is how I'm going to get the negative sign with that. I'm sorry, I put the equal sign in the wrong place. 25 times -1 will give me -25. Right? So now I have a way to get -25 from squaring something. It's from squaring 5i. Right? So 5i squared is how I get -25. So now instead of saying, oh, this is not a real number, we can actually say what it is equal to. It's equal to 5i. Another way you could look at it is if you have -25, you can split the negative sign up from the number. Whoops, jumping ahead of myself. So I'm going to rewrite -25 as -1 times 25. Apply the square root to each number separately. The square root of 25, without the negative sign there, we already know what that is. That's equal to 5. The square root of -1, we just identified, that's equal to I. That's what the imaginary number is. And so square root of -1 becomes I. I times 5 gives me 5i. So that's another way you could derive the answer to square root of -25. You can either think of it as what number squared gives me -25, or you can process it this way. And I usually don't bother writing out this much detail. Normally, I just kind of skip to the result. This negative sign ultimately produces an imaginary solution. Let's try to draw a better arrow than that. And then the 25, like I said, we already know how to deal with that, right? Square root of 25 is going to give me 5. And then the negative sign comes outside the square root as an I. And so I just kind of skip to the result there instead of writing out those details. But this is the mathematical background that produces this result. All right, so let's take a look at a couple of examples of this. So let's try dealing with the same way. Sorry, I'm jumbling up my words. Let's try dealing with this in the same way that we just did the previous example, using the shortcut. The negative sign inside the square root ultimately becomes an I outside the square root. That's what after we process it, that's ultimately what would happen with that negative sign. It's going to give me an imaginary number. So I'll get I times the square root of 36, and with the negative sign out of the way, now I can process this like normal. Square root of 36 is just equal to 6. So I get 6 times, sorry, I'm saying it backwards, I times 6, which I will write as 6i. So once you start writing that number I, you kind of treat it like a variable. It's not really a variable, right? It doesn't vary and equal different things. equal to the square root of -1. It's just kind of hiding, it's hiding that square root of -1 behind this label, basically. But once we have it as this label, we kind of treat I like a variable in a lot of cases. So if I had x times 6, I would write that as 6x. I'm going to do the same thing with I. All right, same thing happens here, right? This negative sign will get processed by the square root and come outside the square root as an I. This negative sign outside the square root, nothing happens to it. We're just stuck with it. So I'm just going to copy it down. And now that we have 49 by itself, we can process that. Square root of 49 is just 7. So I'm going to get -I times 7, which is -7I. And that would be the answer to that one. All right. Now what's going to happen is we're going to start having imaginary numbers like 7I or 6I interacting with regular numbers, like real numbers, like 5 and 2. And because they're different from one another, they cannot be combined together. And so a lot of numbers, once you start mixing in real and imaginary numbers together, a lot of numbers are going to have two components. They will have a real component, which here is being labeled as A, and they'll have an imaginary component. And you're just stuck with those two components because you can't combine those together. Whenever a number ends up like this with a real part and an imaginary part, it's called a complex number. So a complex number is a number of the form A plus BI. Now, sometimes the real part could be 0. So if you have 0 here for A, then your number is just BI. It's just an imaginary number. So imaginary numbers are part of the complex number set. And then you could also have 0 for the imaginary part. And so you'd have A plus 0I, which would just be A. And so real numbers are part of the complex set of complex numbers. So let me say that again. Just the real numbers are part of the complex numbers, and just the imaginary numbers are part of the complex numbers. And any combination of the two, real and imaginary together, compose the set of complex numbers. All right. But most of the time in this section, your complex numbers will have both parts, a real part and an imaginary part. All right. So what can you do with complex numbers? Turns out you can do the same thing with those as you do with regular numbers. You can add or subtract complex numbers. You can multiply or divide complex numbers. You can square complex numbers. You can pretty much do any other operation you can do with regular numbers, you can do with complex numbers. We're just going to focus on adding, subtracting, and multiplying. Division is available in this section, but I have decided to skip dividing complex numbers because it never comes up. It's never something that you need to be able to do. It is possible to do that, but whenever, like when you take college algebra, for example, there's never a situation where you have to divide complex numbers. There are situations where you have to add complex numbers and subtract them and multiply them, but there's never a situation where you have to divide. And it's kind of complicated, so I'm just going to skip it. So to add or subtract complex numbers, we're going to just combine like terms. You treat I like a variable. You treat it like x. So that one's pretty simple. To multiply complex numbers, things are a little bit more complicated. You'll either distribute or FOIL, depending on the situation. And the thing that makes it complicated is you have to remember that I squared, by our definition, I squared is equal to -1. Let's just circle it. All right. So whenever you see I squared, you replace it with -1 because that's simplifying it, right? Instead of leaving it as I squared, we're going to simplify it to just -1 because I squared is equal to -1. So we treat I like a variable in as much as we can, but once we get I squared, we don't treat it like a variable anymore. I squared is equal to -1, so we swap it out. All right, so let's look at some examples. Sorry, I skipped a page. So here we want to add these two complex numbers together. The parentheses do nothing here, mathematically speaking. They are only here to delineate, here's one complex number, here's another complex number. So one complex number is 7 minus 9i. The other complex number is 7 minus 4i. And we want to add those two complex numbers together. So we can just drop the parentheses. They don't really do anything mathematically. And then we just combine like terms. Treat I like a variable. So 7 plus 7, those are like terms. We add those together, we get 14. Negative 9i minus 4i gives me negative 13i. Those are like terms because they both have an I, just like if it was 9x and 4x, they would be like terms. And we get another complex number. That's our final answer. So you just combine like terms and you get another complex number typically. All right, we'll do the same thing when we subtract, except there is one mathematical, necessity with these parentheses. You can't just drop them like we did over here for addition. We have 7 minus I, but then we want to subtract this complex number, which means we want to subtract every part of that complex number. And so before we can drop these parentheses, we have to distribute that minus sign to each term inside the parentheses. So that is one mathematical purpose for the second set of parentheses. The first set of parentheses has no mathematical purpose, but the second set of parentheses does. So we distribute the negative sign, we'll get negative 8 minus 7i. And then we combine like terms. So after you distribute the minus sign, combine like terms just like in the last problem. 7 minus 8 will be negative 1. And then negative I minus 7i, just like negative x minus 7x, it's going to give me negative 8i. I treat I just like a variable. And you want to keep it in this order. So Math Excel, I think, might be kind of picky about the answer has to be in the form a plus bi. The real part goes first, the imaginary part goes second. The real part here is negative 1. The imaginary part is negative 8i. All right, so you subtract two complex numbers, you get another complex number. All right, now here we're going to be multiplying. In the first case, we'll just distribute. We have 8i, that's one complex number. The real part is 0, right? This is a case where this is still considered a complex number, but the real part is 0, it's missing. That complex number 8i is being multiplied to this complex number, which is 8 minus 8i. And so to multiply these together, we'll just distribute the 8i into the parentheses. So we'll get 8i times 8, which is 64i. Positive times a negative is negative. 8i times 8i is 64i squared. Please get that part right. So I know students would know better. If it was 8x times 8 minus 8x, everybody would get this right. They would get 64x minus 64x squared. Nobody would make a mistake with that x squared. But for some reason, I don't know what it is, when I grade this test on chapter 6, when students are multiplying i's together, they forget to put the square. And they'll just have 64i here without it being squared, even though if it was x, I know they would put x squared. And that's a really critical mistake, because you might think it's just a minor typo or something, but a big part of this problem that I'm grading you on is, do you know what to do when I squared shows up? Right? We just talked about it a moment ago on this screen. Whenever you get I squared, you have to replace that with negative 1. I'm testing you to see if you know to do that. And so if your work never produces an I squared, I don't get to see if you would know to replace that with negative 1. And so you end up losing quite a lot of points if you make that little mistake. So be careful about that. I squared is equal to negative 1. So we replace the I squared with negative 1. We're simplifying it. And then we'll multiply these together, right? So negative 64 times negative 1 makes that a positive 64. And while mathematically it'd be fine just to leave it like this, Math Excel is kind of picky about the way you format the answer. Real part has to go first. So 64 goes first, and then the imaginary part goes second. So it's going to be 64 plus 64i. So even though momentarily our result becomes something more complex than a complex number, right? We have I squared here. Once we simplify it, our answer becomes another complex number. So this is another good thing to remember. Whenever you multiply two complex numbers together, your answer should just be another complex number. If you leave I squared in there, it's not in the form of a plus bi. And it should be. Anytime you multiply complex numbers together, the answer should be another a plus bi. And so that might prompt you to simplify. Or if you forgot to put the square here, you might go back and say, wait a minute, something's missing from my problem because I'm not getting it in the form it's supposed to be in. Right. So here what we're going to do to multiply these is FOIL. So there's two terms here, there's two terms here. That's when you do FOIL. So we'll multiply the first terms together. 8 times 6 is 48. We'll multiply the outer terms together. Positive times a negative is negative. 8 times 3i is going to be 24i. We'll multiply the inner terms together. Positive times a positive will be positive. 5i times 6 will be 30i. And then we multiply the last terms. Positive times a negative is negative. 5i times 3i is 15i squared. I'm not exaggerating. I get a lot of students. I mean, maybe it sticks out more in my mind because I'm just kind of in disbelief that students will make that mistake, but it's pretty common. I mean, I will get at least 25% of my test where students are missing that square. Maybe not that bad even. Maybe it's 15 or 20%. But still, it's a large enough proportion that I want to make sure I emphasize this when I'm teaching it. I times I should give you I squared. Now we're going to go to simplify this. We'll combine like terms, and right now, just these two things are like terms. Right? We have negative 24i plus 30i. That combines together to give me positive 6i. I'll just copy the 48 down. This I want to simplify by replacing the I squared with negative 1. Right, and so we'll have negative 15 times negative 1, which becomes positive 15. Right, so that's what ends up happening from that term. And now these are like terms. 48 and 15 can be added together, and we will get 63. So we'll get 63 plus 6i. And it's another complex number. All right, let's take a look at some more examples. We're almost done. Again, this is another short section. Here we want to simplify this to the form of a plus bi. This problem is here as a bit of foreshadowing of what we're going to see in chapter 7. This expression has the form of the quadratic formula. We haven't talked about the quadratic formula yet in this course because in order to do the quadratic formula properly, you have to know how to reduce fractions. That's why we did chapter 5. So you can learn how to reduce these kind of complicated fractions by canceling out factors. We also have to learn how to handle radicals. And so that's why we did chapter 6 first. And now that we got those two things out of the way, we can now introduce the quadratic formula, which is a very important concept in algebra. And when you use the quadratic formula, you get answers that look like what you see here. And you have to be able to simplify things that look like this. So the first thing you'll start with is dealing with the radical. Let's simplify this square root of 8. Just like we talked about at the beginning of this video, this negative sign transforms into an I outside the radical. Right? That's ultimately what ends up happening with that negative sign, is it becomes an imaginary number. So we'll have 20 minus I square root of 8 over 4. So I'd get rid of that negative sign first, turn it into an imaginary number. Then I'm going to simplify this square root, the square root of 8. I can't take the square root of 8 as a whole, so I will split it up as 4 times 2. Apply the square root to each of those separately, just like we learned to do earlier in chapter 6. Right? We learned how to simplify these earlier in the chapter. The square root of 4 becomes 2. So you have a lot of things going on here, right? You have square root of 4 becomes 2. You still have a square root of 2 here that has to get copied down. And you also have an I that you brought out of the square root earlier, this, in the problem. And so all three of these things have to kind of go together as your second term in the numerator. So we'll still have 20 here, minus, we'll still have 4 on the bottom. So the order I would write this in is I'd put the number first. So because these are all being multiplied, you get to pick the order you write them in, but the standard way of writing it is to put the number outside the radical first, which is 2. Then if there's an imaginary number, put the I next to the 2, and then you put the radical last. And the reason it's a good idea to put the radical last is because if you write it like this, somebody could look at that and say, is that I inside the square root or is it outside the square root? It's kind of ambiguous, right? Unless you make it really, really clear that the square root stops here and the I is definitely outside of it. But even if you think you're making it really clear, it could be debated, right? Is I inside the square root or is it not? And so it's a good rule of thumb to try to keep, whenever you have a term with a radical, to keep everything that's outside the radical in front of it. So there's no debate, right? This I definitely is outside the square root. There's no way it could be inside the square root because it's in front of the radical. So that's why we try to put everything in front of the square root. All right. Then what we can do, what we learned to do in chapter 5, is to reduce this fraction, we have to get factors. And then we can cancel out factors. We have a common factor here of 2. So I'm going to factor a 2 out of this numerator. That's going to leave me with a 10 minus I square root of 2. You cannot factor out a number from a radical. This number that's stuck in the radical is just, like I said, it's stuck there. You cannot bring a common factor out from inside of a radical. So only look at the numbers that are outside the square roots. We have a common factor of 2, so we factor out a 2 from both of those. And then now that 2 is a factor, we can cancel it out with the denominator of 4, which is a factor since it's the only thing down here. And that'll leave me with a 2. Right. And so I'm going to have 10 minus I square root of 2 over 2. I was going to say let's leave the answer like this. That would be okay in chapter 7 to leave your answer like that. But I just remember the directions up here. They want us to write it in the form of a plus bi. So this step right here kind of is unnecessary. I apologize I did that. Because to write it in this form, we're going to have to split this fraction up. We'll take the 2, the denominator, divide it into each term of the numerator to split it up. So we'll get 10 over 2 minus I square root of 2 over 2. Which we could have just done up here and just simplified with the 4 being there without factoring out a 2. So I apologize I did that, but in a way I'm not really sorry because in chapter 7 this is what you're going to want to do in some cases. All right, so 10 divided by 2 is going to give me 5. And then this, I think Math Excel is going to be picky about it. They want the I to be last in that term. So I'm actually in this, because it's being multiplied, we can rearrange it. I know I just said don't put things behind the square root, and now I'm kind of going against that. But I'm not just putting it behind the square root, I'm putting it outside the fraction, right? So I'm going to have square root of 2 over 2 here, and then I is just completely off to the side of the fraction. So again, there's no ambiguity. There's no way to confuse this I as being part of this square root because it's just completely outside the fraction. So you want to write it like that. You would not want to leave the I up here in the numerator behind the radical. That would be a bad idea. All right. And so this is what you would want to type in the Math Excel for this problem. And like I said, I know that might be kind of tough to have simplified, but you want to get good at it because we're going to be seeing a lot of this at the beginning of chapter 7 when we start that chapter here in just a little while. All right. So these are my last couple of problems for you guys to try. So if you would, well, let me say something about this. And then I'm going to say pause the video, try both of these problems, and then resume it to see if you got the right answer. Before you pause the video, what you're going to do with this square is you can't distribute it because you're subtracting here. You can't distribute it. You have to take the base, which is 6 minus 5i, and multiply it to itself twice. So you write it out like this. You're going to have to FOIL that. So go ahead and pause the video. Simplify this. See what results you come up with. Then resume the video to see if you came up with the right answer. All right. So to subtract, like we talked about earlier, you have to distribute that minus sign into the parentheses here. So this first set of parentheses, you don't have to do anything about it. You just get rid of them. You just erase them. So this will be 6 plus 6i. There's nothing else I can do with that. Minus negative 3 becomes positive 3. Minus negative I becomes positive I. So before I can drop the second set of parentheses, that minus sign has to be distributed to each of those terms. Once we've done that, we've dropped the parentheses, we just combine like terms. 6 plus 3 is going to give me 9 for the real part, and then 6i plus I is going to give me 7i for the imaginary part, and that'll be my answer there. For this one, we're going to FOIL. So 6 times 6 is 36. 6 times negative 5i is negative 30i. Negative 5i times 6 is another negative 30i. And negative 5i times negative 5i is 25i squared. I know I've emphasized it every single time. I'm going to emphasize it again. Make sure that you get that squared, right? I times I is I squared. And when you get I squared, you replace it with a negative 1. So this is going to become 25 times negative 1, which is negative 25. Right? These combine together to give me negative 60i. And then I'm just copying down the 36 for the moment. But once I replace the I squared with negative 1, these terms become like terms. So 36 minus 25 is going to be 11. So we get 11 minus 60i as our final answer here. All right, so that concludes the video on section 6.8 on complex numbers.